for the environmental activist community. She's a very wise person. And I should say, Ruth Bader Ginsburg, similarly, who's helped us all march forward one step at a time successfully in getting gender equity rights. You know, as a bisexual, genderqueer person myself, she's a hero of mine for my own personal reasons as well as societal. So thank you, Ruth Bader Ginsburg. So with that, I'd like to transition into what I expect to be a totally amazing presentation here. Emmy LaFountain is going to be presenting. Let me grab her. There we go. So she is the Sustainability Project Manager for Turner Construction. She's based out of Northern California, but operating at the national level. So Emmy's primary focus is developing Turner's Embodied Carbon Reduction Program. Woo, woo! And managing its 2030 commitment to reduce job site carbon emissions and water consumption by 50% over the next 9 years. Yes. In this 30-minute segment, Emmy will speak to Turner Construction's efforts to reduce both job site construction emissions and embodied carbon, as well as how owners, designers, and engineers can engage with contractors to maximize carbon reductions on a project. Thank you, Emmy. I'm delighted to get to see your presentation. Can you, there you are. Hello.
Yes, hi, thank you for having me. Thank you so much.
Well, really, the honor is mine. Thank you for being here. So could you bring up your slides?
Yes, let me see if I can get this going.
Perfect. If you put it in presenter mode, there you go.
Can we see that? All good?
Everything's good. Everything's great. Okay, take it away. Have a great one.
Thank you. Well, thank you so much for that awesome introduction. I am honestly just so excited to be talking to you guys today. This is an awesome crowd of thinkers and policymakers and change makers. So thank you all so much for your time, and really excited to go over some of this stuff. So first of all, I guess I better introduce again that I'm going to be kind of focusing on the contractor side of decarbonized construction. And I got to say, this is kind of an area that has historically been kind of neglected. And because in the past, when we talked about green buildings, we really just kind of focused on this use stage of the green building. And this, you know, was the conversations, albeit very important, incredibly important conversations about building use and operations. But if you take a step back, there's this whole other part of carbon associated with buildings that's historically been really neglected. And I'm sure many of you are already familiar with this chart, but this goes all the way from blowing apart a mountain to extract the materials, all the way until you throw some material away in the landfill. There's waste along that whole process, and there's plenty of opportunity, is how I would phrase it, to reduce carbon consumption during the building's life cycle. And so I wanted to talk about two things, but the first of which is kind of the more obvious scope, which you might be thinking of for contractors to cover, which is the A5 and C1, we call this construction and deconstruction scope emissions associated with a building. And we assess this because, you know, aside from just building green buildings, we have to ask ourselves, how can we build buildings greener, right? And as a response to that question, we came up with this goal back in 2019 as a company to reduce our greenhouse gas emissions and water consumption of our on-site operations by 50% by the year 2030. Now, Turner's a pretty big ship. We are the largest commercial contractor in the United States. So this has the potential to create a fairly big wave across our company by making this commitment. So we're really thrilled to make this commitment, but it did kind of raise the question, how are you going to get there? And to start off, we had to say, well, okay, if we're going to be reducing by 50%, what are we going to be reducing from? And so for the past 2 years, we've been using this platform called Building OS to measure our total life cycle carbon emissions associated with construction. And so what I'm going to talk about a little bit today is about some of the trends that we've been observing from the past 2 years and how we're addressing that carbon reduction as well. Now, this does apply to water as well, but I think that kind of the more pressing issue that we're addressing today in this conference series is carbon. So I will be mentioning carbon quite a bit. Now, it is worth mentioning, we are measuring 3 things on this platform, and that is fuel, electricity, and water. And you can measure it all manually. You don't have to use this fancy program if you don't want to. There's plenty of options out there. You could use a glorified Excel spreadsheet if you wanted to, and use the carbon intensity factors for each fuel source that you use. But this is what we've been using. It's been really helpful for us. It also allows us to see our live usage trends. So we've been really pleased with this platform, and we continue to measure about 70 projects using it. And so just to kind of dive into some of the findings that we've had with this program, one of the major findings we've been seeing is that it's really important to get off of generators. And most people don't want to be on generators because it's more expensive and you have rental and fuel costs. But when you look at it from the carbon perspective, it makes a lot of sense to get off of it, because if you look at the purple being the generator fuel carbon emissions versus when you finally get on temporary power for construction, then green, you can really see that the carbon emissions associated with the generator are about 5 times higher than when you finally electrify the job site. So this is a theme that we've been hearing repeatedly for the built environment, that it's important to electrify. Construction is no different, and this kind of puts the numbers to that logic as well. So really, really important finding. You'll notice also there's a little dip here in April. That is because of COVID. Another justification for electrifying, we've got 2 projects here, both in scales of 0 to 300 tons of carbon. But the green bar here is showing heat carbon, so temporary heating, right? Same over here on the right, we've got the green bar associated with temporary heating, but the major difference between these 2 projects is the project on the left is using natural gas heating, as opposed to a project on the right, which is using electric heating. And you can see that the project that used natural gas heating is about 15 times higher than the project that used electric heating. Now, it is worth mentioning, this is Chicago. It is significantly colder than Sacramento, so do take it with a grain of salt, but it does kind of put it in just perspective, even with that being said, about how different the carbon portfolio associated with an electric building is compared to a natural gas building. Another big finding that we've had looking at the data is once you get onto permanent power, this is the activities associated with commissioning phase of construction. You can see this huge jump in power consumption. So really, when we talk about electricity use during a project, this is really kind of the largest chunk of the pie that we need to address as an industry. Another interesting finding that we found by putting meters on our project is that the majority of electrical use actually tends to happen off hours when nobody's on site. So you can see the weekends, you can see the nighttime consumption is much higher. So it does kind of, we've all heard about vampire power and the loads that happen when we're not thinking about it. But this is kind of a new perspective to put on energy use during the nighttime. And it does kind of make you think, when you drive by a construction site at night, a lot of times it's lit up like a Christmas tree, right? And so what are we doing as an industry to reduce job site emissions associated with electricity use when nobody's there? Another major finding is that a lot of the carbon emissions associated with construction happen understandably with the site work. And so when you have all that earthwork happening in the beginning phase of the project, that's really where the bulk of your fuel-related carbon emissions happen on a job site. And so you can kind of see this big peak in the beginning, starts to taper off once you get into the finishes type work. And so what this kind of starts looking like is a bit of an M shape, where you have a big jump in the beginning associated with site work, kind of dips down in the middle when you're doing finishes, and then again it jumps up again in the end with commissioning. And now you might have a little jump in here associated with heating during the winter, but it's a notable trend that's worth noting, and something that really hasn't been paid much attention to historically with respects to green building. So this is where we've been putting a lot of our energy. It's enabled us to really kind of focus our energy on the biggest chunks of the pie first, and it is, like I said, you can do it with an Excel spreadsheet if you wanted to, but we are using this platform. So it's a pretty accessible way for contractors to analyze their footprint and start making strides towards reducing it.
Can I ask just briefly on that side, during the month of September, that big old peak, what is an example of gasoline usage that's happening? And then there's temporary natural gas. Seems like during this commissioning, what's happening there that's using these huge amounts of fuels?
Well, I want to say that this is actually GRs. I know that these colors look very similar, but this is actually contractor related fuel emissions. This is a bit of a special scenario because they were not able to go directly onto permanent power in this instance. There was a bit of an issue between getting off of temporary power and going on a permanent power. And so they filled in that gap by, again, hiring a generator to come in so that they could start the commissioning activities of the building phase.
Oh my. I mean, that's, as a commissioning agent, that is important to me to understand. Great, thank you.
Yeah, no, the generators are really kind of an enemy on the job site, to be honest. And so what I wanted to mention too is, looking at this big jump in the beginning, where all this heavy equipment is coming from, the direction that it is pretty clear that we do have to electrify, and that seems like a really daunting ask, but the reality is it's actually already started, the electrification process. And when I get into the later slides, I'll show you some examples of what we're doing on the Turner job sites, but I do want to say that some places have already started electrifying. Oslo, notably in 2019, started the world's first zero emission construction site, and I think they've got about 3 or 4 in the works right now, using all electric equipment. So it does kind of sound like the super futuristic thing, and it's a nice idea, but we can never do it. But the reality is it's actually already started to happen. And so here are some examples of what we're doing. One EPA study found that an analysis of class 7 heavy equipment you idled about 40% of its operating time. So again, if you think about the 50% reduction goal, well, if we're idling 40% of its operating time, that's really low hanging fruit, right? That's for free. Those are free carbon savings available on the job site. So last year, we did roll out a company-wide no idling standard. We did not put a time limit on it with the assumption that nobody's gonna go out there with a stopwatch. So we just said, all right, starting now, we are going to start a culture where it is not okay to idle on a job site. So this is, going to be a learning curve. It's going to be a culture shift, but it's one that it's really important for us. Makes a lot of sense. Saves gas, saves money, improves air quality. This is just really a no-brainer on construction job sites, and it's also really important because heavy equipment, notably, doesn't have the same environmental regulations as, say, a commercial vehicle, right, where you have catalytic converters on everything. They are a different class of equipment, so they're subject to different environmental regulations. So this is something really important to keep in mind. The year before that, we implemented an all LED temp lighting standard. We just said we're going to do it, and we did it, and we have gotten no pushback on this. This was one of the easiest things that we could have done. I'm sure it saves a ton of energy on our job sites. Again, kind of going back to that overnight lighting comment, but 5 years ago, we were under the impression that this is impossible. But again, standard across all Turner job sites at this point. We've also started looking a little bit at more of the bigger picture equipment that you would see on traditionally on a job site. So hybrid light plants save about 99.3% of fuel emissions compared to a regular diesel light plant. They have the added benefit of having a timer on it, so you don't have to have your laborer go around at the beginning of every day turning things on. Same idea with solar cameras. We've got hybrid and electric boom lifts. So if it's not moving up and down, you can just cut the engine and it's not burning any electricity or fuel. We've started the transition over to electric forklifts, especially, a lot of these photos are from one of our data center projects in Iowa. But they've said for the newer project in that data center series, all that interior construction of equipment is going to be done with electric equipment. So this is a great example of one of those tools we'll use for that. All electric air compressors, again, one of the just really low-hanging, easy implementable items. Rebar shears, pretty nasty stuff when it's not done with electric equipment, but really easy to get electrified. Sounds simple, but using mass transport on the job site, so you don't have people driving around their own personal vehicles all the time to get to the job site. This saves on a lot of parking as well, which is an added benefit for logistics. Electrifying temporary heat. This doesn't necessarily work in every region. I will point that out, but it is an option that is out there, and this is an option that we have elected to take again for that data center project out in Iowa. And then there's kind of this more leading edge equipment too that we are working on procuring if we have not already. So I wanted to just let you guys know about kind of the state of the market for some of this equipment. This is a electric crawler crane from, I think it's Lieberman or Lieber over in Germany. We are working on acquiring one of these for our job sites. Cranes do tend to use a lot of fuel in the construction process. So this would be a big win if we can get this. Payloaders are getting pretty close to becoming, commercially available. We have acquired a couple of these as pilot pieces of equipment on, again, the Iowa job site, and we're testing that out to see if it's scalable. Electric backhoes, again, we're starting to see this become a little bit more mainstream from equipment providers. Skid steers, there's some pretty awesome ones. This is the 165E. And we're getting one of those on the job site. Handles really well, really responsive. Concrete trucks, I will say that this one's a little bit farther out in terms of being able to see this on the road anytime soon. But we are starting to ask these questions, and it makes a lot of sense to have these be electric, especially because, when they're pumping concrete onto a site, they run the entire engine just to run that thing. So it makes a lot of sense. As it's stationary, we cut the engine and then we can still run the mixer in the back. Generators make a ton of sense. Generators have to run basically at 100% to avoid having any kind of buildup in the engine. And so what hybrid generators or battery packs attached to them have the ability to do is you charge that battery pack. When you have low level loads, you can turn the generator off, and then that battery pack will feed those lower level loads that would cause buildup in the engine anyway. So this makes a lot of financial sense for maintenance as well. Telehandler, we're seeing a lot of electrification in this realm. UTVs, super easy to electrify, right? If we were able to get a man on the moon in the 60s, we can probably electrify a golf cart for construction purposes. So we have ordered quite a few of these, there's some room to grow. We're kind of waiting for the lithium ion market to take a better hold on the UTV market before procuring a bunch more of these. But they handle just the same, and you're not driving 8 hours a day on these things, so this makes a ton of sense as well. Hybrid Ford F-150s and electric Ford F-150s, I think, are coming out this year and next year, respectively. So we are looking forward to procuring a few of those for our job sites. Obviously, each superintendent has one of these huge trucks that they're driving around with, so this would be a big win if we can electrify this, and a big win for our carbon footprint. For some of our bigger projects, again, when you have buses shuttling people around to the different parts of the project, buses can make sense, or hybrid buses make sense in those applications rather than having them be diesel powered. The Caterpillar D6 XE dozer is really exciting for us. We've gotten really great feedback from our subs who, regardless of their interest in fuel economy, have just said that this is a really great piece of equipment, that they really enjoy working with it and that it handles really well. So we really are excited about this one. And then excavators as well, both for exterior and interior applications, although the interior ones, these are kind of smaller than your other pieces of equipment. So all of these pieces of equipment that I just mentioned, we have either procured or we're in the process of procuring and testing. And we are getting serious about the scalability of this on our job sites as a whole. And already, as evidenced by our no idling policy and our all LED temp lighting policy, we have started kind of adopting those measures as they work for our company and they prove economical, to scale it up a little bit for future projects. And whenever we make this case, I'm a sustainability person to my very core, but when we make the case to a big 10,000 person group company, we can't just say it's good for the planet. So every time we approach one of these new pieces of equipment, we approach it with we call it the quadruple P system. You might have heard the triple bottom line, but we add another P to it. So it's people, planet, profit, and project. How does it benefit all of these categories, including maybe we can get some lead points on it or whatever it is. But we do kind of an analysis of all four of these categories in order to justify scaling the practice up to the whole company. So that's the A5, C1 kind of side of the equation. I'm just going to quickly touch on embodied carbon because I know you guys have been learning about it all day today and yesterday. And this is definitely something that's really been booming in the last few years, and rightly so, given that concrete is about 8% of global carbon emissions and steel's another 7%. So we've been paying a lot of attention to this too. I know we're kind of getting up to the end of our time together, but I wanted to just mention that and I know every presentation you love having a good list. So I put kind of 10 points on how you can involve your GC, because a lot like the rest of green building, a lot of it has been focused on what the designer can do. And absolutely, the designer has a ton of power on lowering the embodied carbon of a building. But I did want to highlight that the general contractor is a really great ally in this conversation. And so 10 things that you can ask from your GC, I'll just kind of go through each of these with you. Number one is trade partner outreach and education. We are ultimately the ones who kind of hold the wallet in terms of buying the services and materials from our trade partners. And so with kind of the network that we have established, it does really make sense to utilize your general contractor to outreach to the trade partners and make sure, do they know what an EPD is? What are your options for reducing embodied carbon? And having them engage with them early on at the very beginning of pre-construction. So when it comes time to comparing EPDs, you have a bigger arsenal of materials that you can look at and compare.
Yet they say what an EPD means in full words.
Oh, yeah, sorry. So an EPD is an environmental product declaration. You can kind of think of it as a nutrition label for a material in a building. So for example, this per every square foot of drywall, for example, you can expect a global warming potential of X tons of carbon or kilograms of carbon. And so the idea is that you can get an apples to apples comparison of different materials on the market and select the material that ultimately demonstrates a lower embodied carbon footprint. Thank you. Number 2 on this list is write in design build designer performance criteria for embodied carbon reduction, and don't forget the piles and curtain wall. So even if in the traditional design bid build process, you have your structural engineers working on embodied carbon reductions, keep in mind too that many times general contractors have it written into their contract to do some design assist or design build components of the building. Commonly, common examples are piles and curtain wall and a few others. Since those are different structural engineers than the project structural engineer, it can be easily forgotten, but the curtain wall and piles especially are really big carbon footprints on a project. And so if that expectation is not clear with your general contractor, that big kind of hidden carbon footprint of the piles or the curtain wall may get neglected. So it's really important to remember to write that into the performance criteria. Again, talking about EPDs, the contractor is the one who's going to be writing in EPD requests into the bid documents, and they have the ability also to request global warming potential estimates alongside cost estimates. Again, that early procurement stuff is done by your general contractor. If that expectation is not made clear with them, it will probably get missed. And so don't forget this opportunity when engaging with your general contractor. Another point on here is to bring in trade partners as field experts to collaborate and identify ways to lower embodied carbon. Designers, I love you, but as much as you know, these trade partners work with these materials every day. And so if you're not leveraging the knowledge that's in-house with these trade partners, I would call it a missed opportunity. And so don't hesitate to ask your GC to facilitate those conversations so that the designers and these experts in the materials have an opportunity to identify that best pathway to reducing embodied carbon. Number 5 is to provide multiple EPDs during the submittal review process, if applicable. So I'll show a snapshot of what that looks like later, but for example, concrete. You can ask for multiple EPDs for different mix designs from that concrete supplier. It just means asking the question, and you can add that as another thing to review alongside slump or whatever you want to review in there, water content. Number 6 is to verify the feasibility of project embodied carbon reduction targets for certain materials. So if an architect says, we want a 30% reduction across the board for every material, the general contractor might come back and say, we can't actually get 30% reduction for, your studs or whatever it is. It really needs to be kind of analyzed on a case-by-case basis. So it's really important to ask that question ahead of time. Number 7 is to participate in the embodied carbon gut check meetings during design with the design team. So again, please do not exclude your general contractors from the embodied carbon discussion. We can definitely help during early phase pre-construction meetings oriented towards design. And when we do that, we have the ability to bring in our expertise on things like concrete and provide a better maybe design optimization given certain market conditions. Number 8 is a quick tip to use maturity curves set by concrete sensors to accelerate construction or reduce cement. Concrete sensors are these sensors that are embedded into the concrete as it cures. It measures heat and temperature and time, and it sets that maturity curve that you can analyze strength against. And so using this will allow you to identify when you've met optimum strength. And if you wanted to pull forms a little bit earlier, or if you wanted to use that data and say, what, we are over designing, we can reduce our cement content for later pours. So that's a quick tip. Number 9 is to integrate embodied carbon into the Revit and BIM 360 models using software like Tally or EC3. So again, a lot of contractors have in-house VDC teams, virtual design and construction teams. And so by asking them to integrate embodied carbon into that model, you can easily get a gut check on where you guys are falling on embodied carbon versus your goals. And number 10, and this is kind of an homage to my earlier slides, please track carbon during construction. It's such an easy win and really straightforward. Anybody can really do it. So those are kind of my top 10 tips. You can get complicated with EC3. You can make these beautiful graphs, but I mean, sometimes you can just even ask for, like I had said, 2 mixed designs. Just ask the concrete suppliers and say, all right, same performance criteria. What kind of mixed designs do you have and what's the relative carbon footprint? And it can be as simple as this. And we looked at this and said, all right, really straightforward. We'll do mixed design number 2. And we saved, however many pounds of carbon that way. So in summary, I know I'm short on time, but I just want to ask, let your GC be an ally introducing embodied carbon, not just chasing down EPDs for lead, right? We can be so much more than that. And I would venture to say that we can really help facilitate that journey so long as you involve us and make sure that the expectations and goals are clear upfront in that. So with that, I think we've got 3 minutes left. I don't know if there's any time for questions or if you wanted to wrap it up, Sean.
Well, hey, whoop, whoop, whoop. Man, that was amazing. You guys have conquered this topic. That was such a fantastic presentation. That was par excellence. Man, good learning there. Okay, over on the side, Nicholas Carter wants to point out a mini excavator. You can just there's different comments. People are excitedly sharing things and questions. There's a question here of, can you usually count on 240 volt electricity already installed on a job site?
I'm assuming that's for supplying the need for electric equipment. I mean, the voltage, and it depends equipment to equipment. I certainly can't prescribe voltage, a single voltage for your entire equipment fleet. But what I will say is that, amperage needs do need to really be considered upfront during logistics planning, and especially when you're figuring out how much electricity to feed to the job site during that temp construction phase. So that needs to be figured out with your utility company. And also the MEP estimator from the construction side needs to be aware of the amperage needs associated with charging during construction. So I can't say 240 volt. It varies, but just know that the amperage demands as we transition to electric equipment are going to naturally increase. So definitely something to want to consider.
Well, Hannah Kay is still here over on the attendees side now, and she was PG&E. And when I think it was also Kelly, they were co-presenting. This is the kind of policies that we could add to the list of PG&E to address, which is how to deliver as much electricity as you need immediately to job sites, to have some sort of accelerated deployment of temporary power, for example, since that was just a massive carbon impact that could be avoided by, the equipment, which we could also fold into CEQA for any people who think about CEQA, having electrified equipment. But Anyway, I just want you to know that PG&E is listening.
Fantastic. Well, I'm always happy to engage in conversation. I actually took my presentation down, so you don't see my email anymore. I'll throw it back up. But always happy to stay in touch if you have any questions about kind of some of our findings.